Today, in this lesson, we're going to be learning about concentration and molar gas volume. Concentration is a measure of the amount of elementary particles in a specific volume. This can be expressed in a specific way, number of moles per cubic decimeter. That's how as scientists express concentration, number of moles per cubic decimeter. So concentration is a number of moles divided by volume, which can be written as C is equal to N over V, where your C is your concentration and it's measured in moles per decimeter cubed. Please note that that's your SI unit, moles per decimeter cubed. N is the number of moles and V is the volume, and again it's measured in decimeters cubed. So let's look at an example. In this example, we're going to be trying to find the concentration if we take 3.5 grams of sodium hydroxide and it's dissolved in 2.5 decimeters cubed of water. So we've got 3.5 grams of sodium hydroxide and it's dissolved in 2.5 decimeters cubed of water. So first of all, you have to realize that we need to find the number of moles of sodium hydroxide. So because they've given us the mass, so we need to find the number of moles. So we know that the number of moles is mass over molar mass. Sodium hydroxide is NaOH, okay, NaOH, and if you look on your periodic table, you will see that the molar mass of sodium is 23, plus the molar mass of oxygen is 16, plus the molar mass of hydrogen is 1, which gives us a 40. And that's where we get to this number. The molar mass of sodium hydroxide is 40. So we get number of moles is mass over molar mass, which is 3.5 divided by 40, which is 0.075. Right, so now we've got the number of moles and we have the volume, so we can calculate the concentration. So concentration is number of moles over volume, which is 0.0875 divided by 2.5, because that's in decimeters cubed, we've checked, and that gives us 0.035 moles per decimeter cubed. Please remember your unit, 0.035 moles per decimeter cubed. Okay, right, now let's look at the molar gas volume. 1 mole of gas, doesn't matter what it is, but it takes up or occupies 22.4 decimeters cubed at a specific temperature, and the temperature is 0 degrees Celsius, or another way of saying it is 273 Kelvin, and 1 atmosphere, or 101.3 kilopascals. So 1 mole of gas occupies 22.4 decimeters cubed at a specific temperature and pressure. And these specific temperatures and pressures are called standard temperature and pressure, STP, standard temperature and pressure. So the standard temperature is 0 degrees Celsius, or 273 Kelvin if you're using the Kelvin scale, or it's 101.3 kilopascals, or 1 atmosphere. So now, please understand that the reason this is only at STP is because obviously we know that a gas, what does it do if it gets hot? It expands. And what happens with pressure and gases and volumes of gas? As we increase the pressure, the volume goes down. So basically this is only at STP. So what that means is that equal volumes of gas under the same conditions of temperature and pressure will have an equal number of molecules. So for example, if we've got 10 cubic centimeters of hydrogen and 10 cubic centimeters of oxygen, we'll have the same number of molecules if we're at STP, but only if we're at STP. 2 moles of any gas would therefore occupy 44.8 decimeters cubed at STP. So if 1 mole of gas occupies 22.4, then obviously 2 moles of any gas will occupy 44.8 decimeters cubed at STP. And that's all you need to know at the moment for concentration and molar gas volume. Please make sure that you've studied this, that you can do the calculations and go do the assessment at the end of the section. Have a great